This is the Higher Physics Multiple Choice Paper 2010, questions 1 to 6. Question here really saying, what is acceleration? What you should be thinking of is A equals V minus U over T. The top line is a velocity and the bottom line is a time, so it's velocity per time. So what we're having to do is to look in our example here, which one of these gives a velocity per time, and answer C. Second question here, what you're really thinking of is you're trying to say which is the matching velocity time graph. The gradient of a velocity time graph gives you the acceleration time graph. So we're looking for a velocity time graph where the first section is a positive gradient and the second section is a negative gradient. And if we look at our graphs, this one doesn't, this one doesn't, this one doesn't, this one doesn't, this one does. E is the correct answer. This type, mainly calculation. What you have to do is ignore the potential answers and consider the calculation. We're looking for kinetic energy, which you should know is a half mv squared. For the potential energy at the beginning, it's a half times 1,000 times 40 squared. That works at 800,000 joules. After, it's still a half mv squared, so it's a half times 1,000 times 10 squared. That works out at 50,000 joules. The difference is 800,000 subtract 50,000. Answer is 750,000 joules. Answer is in kilojoules, so we need to convert into kilojoules by dividing by 1,000. D is the correct answer. This type of question here to do with relative densities. We know that we have the same mass of the substance, but when we change its state, the spacing changes. The solid and the liquid relatively have equal spacing, so we'd be looking at the number here and here to be the same. And these numbers are the same, so they would be considered. This one we can rule out because they're not the same. When it changes from a liquid to a gas, the volume increases by 1,000. So the density is mass divided by volume. That volume increases by 1,000 times. The mass doesn't change, it stays the same. So the relative density would decrease by 1,000. If you look at line A, 1,000, 1,000 equal, and then the next step is decreasing by 1,000, which looks like the correct answer. This one, it doesn't. Again, it doesn't. And again, it doesn't change. A is the correct answer. Again, calculation type, best thing to do is to ignore the potential answers. It's looking for pressure. Pressure equals rho times G times H. Let's look at the values. Density 1.03 times 10 to the power of 3. Gravity 9.8, and the depth is 10.4. If you multiply all of that out, you get an answer that is, there is 1.049 times 10 to the power of 5. The value that agrees with our answer is this one here. 5D is the correct answer. This one here, looking for temperature difference bar in degrees Kelvin. So the temperature difference is equal to the temperature after, take away the temperature before, what it's in degrees Kelvin. Temperature after is 80 plus 273. Subtract the temperature before, which is minus 10, but add 273, convert it into Kelvin, and we get 80 plus 273 minus 10 makes positive 10. Minus times positive is minus 273. The 273's cancel out, and I get a value equal to 90. B is the correct answer.